Hello, and welcome to another episode of Risky Business. We just spent like 35 minutes compiling the Freedom E SDK, but it's compiled now. So we can continue playing with our HiFive1. So let's see here. We compiled the tools. So to build a C program that will be loaded by the debugger / programmer into the SPI Flash, use the Freedom E SDK to compile. An example is provided in the software / demo _ GPIO directory. So I want to take a look at the actual code. So let's see here. So here is a demo program. So let's take a look and see what all we have here. So we set a frequency. We have some prototypes. So there's this PLIC, and we have some instance data for that. So simple variables for LEDs, buttons, etc. Okay. Here is the entry point for the PLIC interrupt handler. So we'll probably want to take a look at the PLIC driver. So let's start with the header. So we have complete interrupt, claim interrupt, set priority, disable interrupt, enable interrupt, set threshold, init, and we have some type defs, source, priority, threshold. Those are all just on-site integers. And we have this instance struct, which has a base address, num sources, num priorities. Okay. So here is the actual PLIC driver. So I don't know what PLIC stands for, but I imagine we are going to find out. So there's no bounce checking or assertions on this, which is fine in my opinion. So this is volatile mem0. So we pass it base and size, and we have a pointer here, and we say for pointer equals base, pointer is less than base plus size, pointer plus plus, and we just zero. So we're just zeroing out the memory from base to size. And then we have PLIC init. So we pass it an instance, a base address, num sources, num priorities, and it initializes the instance that we passed it with the other parameters. Okay, and then it disables all interrupts. So I haven't taken a look really at the spec yet regarding interrupts, but we are disabling them here. So we have a read CSR, which would be the control status registers. And then we do a mem0. So we're zeroing out the base address of the this PLIC that we initialized. So this is still in the init function. So we pass this in, we initialize it, and then we're zeroing out the memory from the base address to the PLIC enable offset plus this heart ID, which we got from read CSR, shifted by PLIC enable shift per target. Okay. So I think I'd have to take a look at the spec there to fully understand this. But apparently it is disabling all interrupts. And then num sources plus 8 divided by 8. Okay, and then we're setting our priorities to 0. Again, we're just getting the appropriate offset in memory and zeroing out however much we need. And then we're setting the threshold to 0. I'm not sure what the threshold is. I suppose we will find out. And that one we're not using the mem0 that we have. Instead, we're just dereferencing the pointer and setting it to 0. And then here we have set threshold. So we read the CSR, and then we get the threshold pointer from that value that we got from the CSR by doing this computation here. And then we just say that the threshold pointer is equal to, or the value of the threshold pointer is equal to threshold. So we're setting it with that value there. Okay. Here we have one that enables interrupts. So you can see the pattern here is pretty simple. So for pretty much everything we're doing here, what we're doing is we're getting some information off the control status registers of the RISC-V chip, which is what this read CSR is doing. It gives us back an onside long of, I presume, just flags. And then we're doing some math on that to get out the actual information we want, such as an address of a pointer to, for example, we set a threshold here, and then this one is getting a pointer and it is saying the value of current pointer equals current. So let me see here. We have current equals the current one, and then current equals current or, and then this. So some computation there. And then we set that back in. And whatever this does, it is enabling that particular interrupt, apparently. So again, to fully understand this, I think we need to take a look at the specification. But I'm going to keep reading through for now. So then we have disable interrupt, which is pretty obviously just the same thing except going the other way. And then we have set priority. So let's see here. We're saying if we are, if we have num priority is greater than 0, then we have a pointer, which is the base address plus this and some math. And then we're just setting the value to priority, which is what we passed in. And then we have a claim interrupt. So let's see what this one's doing. We have claim address is this here. And then we're just returning the value of it. So this one's just returning a value. And then we have complete interrupt, which, so here we're getting a claim address again, just like in this one. But then we're not just returning it, we're actually setting the value to source. And that's everything in the PLIC driver. So let's return to our proper demo program here. So we have entry point for PLIC interrupt handler. So we do a PLIC claim interrupt, which was this one right here, the one that just returns the value of whatever the claim address is pointing to. And then we're saying if it's greater than or equal to 1 and it's less than PLIC num interrupts. So is this telling us how many interrupts there are then? Or something of that nature? Then we're doing gext interrupt handlers int num. So this would be a table of function pointers apparently, and we're calling a function from it, which, okay, we can see that here. This is the gext interrupt handlers. And there's PLIC num interrupts. So these are the pointers to actual functions to call for interrupts, basically. And then we're saying we're going to call this particular interrupt, is what we're doing here. And then we have, so if it doesn't, if it's not a proper interrupt in this range, then we exit with an error code, which is 1 plus the interrupt number. And then we do PLIC complete interrupt, which I believe was the last one we looked at, which just sets that claim address value. Yeah. So I don't know if you guys are following this, but we'll take a closer look at we'll actually take a look at the specification for interrupts in a little bit, but hopefully you are getting a general idea of what the code is doing other than the details of the interrupt stuff. So we have handle m time interrupt. So this is the entry point for a machine timer interrupt handler. So we do a clear CSR. We reset the timer for 3 seconds in the future. This also clears the existing timer interrupt. So we have mtime is this value, mtime cmp, as in compare, I guess, is that address. So we say now is this, then is now plus 1.5 times RTC frequency. And we saw RTC frequency earlier in the code. That's just a define. So we're setting the timer for 3 seconds in the future. So now plus 1.5 times RTC frequency is apparently 3 seconds in the future then. So then we have the LEDs. So there's G output vals. Let's take a look at that again. So that is this value here, which is from the GPIO stuff. And apparently this is driving the LEDs. So we're setting the value here. So we're doing 1 shifted by the RED, or the red LED offset, and Ring that with the green and the blue. So that makes sense to me. And then we're doing re-enable the timer interrupt. So we set the CSR. Okay. And then here is that pretty little thing. They've got this nice little logo in ASCII here. And so this is a different demo than the one that we have currently on our HiFive1, because this says SciFive demo GPIO program. Every 1.5 second, the timer interrupt will invert Let's, okay, so it is every 1.5 seconds. I don't know why that comment said 3 seconds in the future, because the 1.5 times the RTC frequency, that's giving us however many cycles or whatever per second, right? So that's why it's every 1.5 seconds that it does this. So this interrupt gets called in that frequency. And then it inverts the LEDs, which is what this is doing right here, just with a little shifting and ORing. So it says every 1.5 second, the timer invert will invert the LEDs. So RD dev kit only, press button 0, 1, 2 to set the LEDs. So that is not relevant to the HiFive1, I believe, as the only buttons we have are wake and reset. So then print instructions we call write with the message. So that's pretty simple there. And then we have, so this stuff is if we have those buttons, which I believe we do not. So this doesn't get compiled in. All this stuff right here. And then we have reset demo. So reset demo, I wonder, is this actually what like gets called when you press the reset button or something? I'd think it would just do like a power cycle. So disable the machine and timer interrupts until setup is done. So we clear CSR. So we're setting all these interrupt handlers to no interrupt handler. We skip this, print the instructions. So this is what gets called when you press the reset button and it boots into the program, right? Because like if we connect to the HiFive1 we saw last time, that when we connect to it with GNU screen, we see just like a blank window. And then if we hit the reset button on the HiFive1, it'll like power cycle the board, and then the text gets displayed. And I believe that's what's happening right here. Once it boots into the program, it calls this reset demo function. And then you can see on this line right here, that's where we're actually printing the stuff to the console. So here's some more stuff for if we have buttons. So here again, we're saying set the machine timer to go off in 3 seconds. I don't understand what they mean by that, because it's my understanding is it's firing the interrupt every 1.5 seconds. So then okay, so these bits that we're twiddling here are the machine external bit and the machine timer bit. So we set those back on, and then we enable the interrupts in general. Okay. Now here's main, so this is the actual entry point. So this calls reset demo. Yep, it does right here. And then it just goes into an infinite loop while 1. Yeah, I'm not sure exactly how the interrupts work yet, Miblo. We're going to take a look at the spec after I'm done reading this code. I think we're also going to upload this to the device, of course, too. Oh, that would make sense, Miblo. You are probably right about that. So here we're saying set the GPIOs such that the LED GPIO can be used as both inputs and outputs. Okay. So we do that with a little bit of bit twiddling there. And then we set up the PLIC. And then call reset demo. And then it goes into this infinite loop. So, okay, that makes sense to me. So it just does the infinite loop because there's nothing for it to do. It's just the interrupts are firing. So we are going to try uploading this to the HiFive1 now, and then after that we're going to take a look at this spec for interrupts so we can get a better understanding of that. All right, I am grounded once again. And there is our HiFive1. And I am going to plug it in, and we will see if we can upload this program to it. So let's see if we can connect to it. So we've got the LED fade demo still. And and now we are going to try putting on this new demo. So to do that, we do make upload program equals your desired program, board equals Freedom E300 HiFive1. So I'm going to copy this line. So here is the Freedom E SDK. Now, I am going to say for my desired program, I am going to put demo underscore GPIO. So error couldn't open. That's because we need to do that group business. I still haven't gotten around to that. So we're just going to do this as sudo right now. And it still says error. So I wonder if it's looking in the wrong place then. So we have software. We have demo GPIO. Oh, I see. We need to build it first. So do we... Okay, yeah. So we skipped a step. We need to do this right here. So that split it up into 2 lines. So I guess I'll just type it. So we are saying make software program is demo GPIO board is Freedom dash E300 dash HiFive1. And then we're going to try uploading it. So it says verified OK. Did I misspell something? It seemed like it worked. Oh yeah, I did misspell program. It seemed to work nonetheless though. I don't know why that worked. But it appears that it worked. Okay then. So well, okay then. Let's try it. So if I reconnect to it, Well, that looks a little scrambled. But it says it's doing the demo GPIO program. So I don't know how well you can see that, but the LED is blinking. And it is running the demo GPIO program. So let me try resetting that again. Interesting. So I don't understand why the right is doing this. So this is each time I hit reset. Interesting. I mean, the program seems to be running fine on the actual device. It's just getting the output from it is getting scrambled. You think it was the missing R that did it? So I highly doubt that. I want to try killing strain and then try reconnecting to it. Okay, so it was just GNU screen that was messed up. It doesn't like when you detach from it and reattach, apparently. So actually, before we start looking at the specification to fully understand playing with the LEDs and such, I think I want to do a hello world because that seems fun. So I believe there actually is already a hello world. So if we go to hello, so here is a simple hello world. So apparently we have the C standard library compiled for risc-v because we can do a printf. So I'm just going to say this. We are going to say so this is going to be our first custom program, as simple as it might be. We are going to upload this to the device. So I'm going to say make software. I will correct my spelling error, even though it didn't seem to matter. So we are going to say hello error. What is the error? So it's saying there's an undefined reference to handle m time interrupt and handle m ext interrupt. I don't understand why that would be a problem. For a simple hello world, we're not messing with interrupts. So I guess it's expecting us to set those interrupts, and we're not. Why would they include that with SDK? If you're supposed to set the interrupts, why would they include a hello world program example that doesn't do that? So I am a little bit confused right now. So let's try modifying the demo GPIO instead, because we know that one works. We will come back to the hello world once we understand more about the interrupts. So does anyone in the chat have some pretty ASCII art they want me to replace this logo with? I'm going to replace the text. So I'm going to replace that. Let's see if we can get an image to ASCII converter. We're going to have some fun here. So I want the handmade-network logo. So let's go sitemap. Media and press resources. So we're going to take this here. So let's see. This expects us to upload it, so we're going to download this. So size. We'll just do default and see what this gives us. Well, that didn't seem to work. Let's try a different one. There we go. So I'm going to get rid of this and put that in there. So we want to do this on every line, basically. Or wait a minute. So we have an open. So why is that not syntax highlighting? Ah, I see. So we want basically that on the end of each line. And we want to center this. So let's get rid of this. And now we're going to do a macro. So I'll just put it on A. We're going to say go to the end of the line, add /n/ and then go down a line. So let's see here. We're going to do this at least 36 times. Looks like we want to do it about 41 times. So we are going to say, so there's one, we're going to do 40 more. Beautiful. Oh, and one more. And let's get that /n in there. So this is our beautiful new program, much better than the original. State of the art right here. Some really complex coding we just did. Too late in Miblo, I used a macro. So I am going to upload this. Good call, Quartertron. That is definitely the proper way to go there. No need for numbers. So we are going to rebuild this program. So it did not like that. I think it was just because of that. There we go. And now we are going to upload it. Now, oh wow, it already ran it. So let's do a reset here. And there you can see this beautiful, beautiful program of ours running on the HiFive1. So congratulations, Miblo. You are the first person to be slammed a thunderous high five from the HiFive1. And now, let's see how much time we have. Oh, we are pretty much out of time for today. I need to stop 30 minutes earlier than usual, which is why we didn't do a pre-stream today. Because I have an appointment with an accountant today. So I believe this is all we had time for today. Thank you everyone who watched, and thank you everyone who watches on the YouTube archive, which is available at risky.tv. And if you want to stay up to date with all of our wonderful risc-v shenanigans, as well as everything else we do on the series, you can follow this wonderful at HMN_risky Twitter accounts. So once again, thank you for watching, and stay risky, everyone.